Good afternoon, everybody. We're all just out of lunch. Everybody's beginning to get comfortable. So we've got some exciting stuff to entertain you with this afternoon, right? Yes. That's exciting stuff. So just a little house cleaning before we get started. Everybody's cell phones, let's turn them to vibrate, please. We're also going to leave some time at the end for questions, so let's try to let us get through all of our content first, and then we'll be happy to answer questions at the end. Also, if you have not downloaded the MarkLogic World app, please do. Because after this session, we'd really appreciate it if you'd fill out the survey. That way we know whether we're doing the right things, the wrong things, and we're going to sweeten the offer with a $250 gift certificate registration to win if you fill it out. So without further ado, I am going to introduce John Snelson, who will take over. Oh, you're mic'd.
I'm mic'd.
I'm going to go sit in the back. Enjoy, everyone.
Cool. Thanks for coming, guys. Yeah, of course, this is the after lunch slot, so I'll try to raise my voice randomly during the talk just to wake you back up again. So my name's John Snelson. I'm a principal engineer at MarkLogic, and I lead the team that implements semantics, the SPARQL engine, the SQL engine, Optic API. All of those things run on the same kind of core code. And so today, I accidentally lost the clickbaity part of my title. We're going to talk about semantic graphs in the multimodal context. Okay, so we, as a company, we've heard a lot about Data Hub and a lot about the way that we're integrating data. Now, you may have also come with some conceptions about semantic graphs and RDF and how they work, and what the kind of promise is in that area. Okay, if you have a look at the definition of semantics, semantics is all about meaning. Okay, and meaning. I just wanted to point out this definition here, right? The quote. Okay. Meaning is about relating something you don't know, Hindu word, to something you do know, an English word. That's what meaning is about. So providing semantics, providing meaning to something is about integrating data. And it's about relating things that you don't understand to things that you do understand. So actually, these two concepts, they're actually looking at the same thing from different perspectives. And that's why we think semantics is a great addition to MarkLogic. And we're going to look at how you can use that effectively in MarkLogic. So I've got 4 sections for you. And firstly, I just thought I'd cover some of the kind of technical foundations. What do you need to know about this multi-model database, MarkLogic? So we have the document model in MarkLogic, JSON documents, XML documents. The thing about the document model is, right, as humans, we've been writing documents for centuries and centuries, okay? It's a really natural way for us to model information because, we do it every day. Some of the great things about the kind of documents that we have, JSON and XML, is that they're self-describing and they're human readable. So you can actually go look at this and you can see maybe what might be trying to be represented here. They're very good at representing hierarchy. They're good at representing sequences, and they're good at representing sparse data. Those are 3 things that, if you're coming from the relational world, you're going to have struggled to model. And documents are really good at doing that. And actually, like I say, documents are a very natural way of doing things. We're used to hierarchy in our information because we do that quite naturally. So one of the great things about documents then is also that the schema is flexible. And that goes with the fact that you can have sparse data. There can be things that are there, things that aren't there. You can add in new information. There's nothing telling you that doesn't belong there. And you can, of course, use kind of heterogeneous documents in MarkLogic. Not all your documents have to look the same. They can be completely different. And when you're querying documents, so usually you will be querying documents in MarkLogic through either search or through something that uses our universal index. what we sometimes internally call the CTS queries, because the function names all start CTS. But essentially, that query language, that query system inside MarkLogic is good at finding relevant documents for whatever your criteria is. And it finds the documents and gives you the documents back. And that's your result, is documents. But it gives you access to some great, like full text search technology. It gives you scores. It can do some amount of document positions and things like that. So, we can look at containment and look at hierarchy and query on that kind of thing. If you're adding indexes on top of what we provide with the universal index, you're probably adding range indexes. There's a kind of sorted, ordered indexes. And like I say, you're fetching whole documents. So by comparison then, the graph model, in the graph model, everything is a relationship. Okay? It's built basically to talk about links and relationships. In fact, it's gone so far that there's the only way to even add kind of scalar properties to your information is through another relationship. It's also good for sparse data and very simple merging, by which I mean if you have one set of triples, which makes a graph, and another set of triples, which makes a graph, then you just put them together and they make a bigger graph. It's trivial. Some of the things that the graph model, the RDF at least, struggles to do is represent sequences. It is possible. It's a bit of a stretch, and when you come to query that kind of thing, it's even harder. It is a graph, which means it's directed graph, so the arrows point in certain directions, but there's no innate hierarchy necessarily. You have to define the root to say that that's where the hierarchy starts. So you can do hierarchy, but it's by convention. It's not always obvious what the hierarchy is. And one of the things about the graph model is what it's like. I like to describe it as super normalized. Okay, you know what your third normal form and your fourth normal form, right? If you got someone to see how far they could take normalizing data, how far can you push this concept? You'd probably end up at RDF. You can't get any smaller than RDF, any more granular than that. And that comes with its own set of challenges, particularly when you're querying. So if you're querying the RDF graph, you're going to be querying that with SPARQL most probably. SPARQL is a great little domain-specific language that is really good at navigating the graph for you. And so that's actually a big positive. If you've got a graph-style query, SPARQL is good at doing that and will make you more productive in that way. Yeah, and the way it does that is using graph pattern matching. If you're storing graphs, then the indexes that are going to be involved is the triple index, and we can look a bit about what the triple index is, how that works later. And the data model for a SPARQL query, you might think it's graphs, but in fact, it all works on tables. So the result of a SPARQL query is a table. Again, in fact, I think that's the next slide. We'll look at why that is. Back to the problem of being super normalized. So one of the big problems, though, is that by being such small pieces of information, SPARQL queries have a large number of joins in them. And joins are kind of one of the major problems to be overcome when the query optimizer is looking at how to execute that query. So more joins, it gives you the potential for less efficient queries. So let's take a look at how SPARQL works and the power of that kind of graph pattern matching. So I've got some data up there in the graph, and let's say I wanted to ask the question, which authors, speaking at Semantic Graphs, that's a conference I went to about 5 years ago, wrote a book that I like. Okay? So here's what it looks like as a graph. This is the question. So you can see there's some values in here, Semantic Graphs, okay? And there's some predicates, so I can actually point at this sentence and find you all the parts of this. So authors speaking at Semantic Graphs, okay? Authors wrote a book. And then the book that I like, Here's me, and I like the book. So anywhere we've got question marks there, we want to find an answer. And anywhere we've got values, that's a fixed place in the graph. And if you write that as SPARQL, it looks like that. And in that SPARQL query, you can see each of those edges. There's a little bit, that semicolon is an abbreviation. But basically, you can see the first one, author wrote a book, and then author applies to the next part. So author is also speaking at SemTech and I like the book. Okay. Now, when we run that SPARQL query through the magic of MarkLogic, this is what happens. We match that graph pattern that we've created in the query to the same pattern in the data. And when we do that, we find the values that are underneath those question marks, and we return those as rows in a table. That's your results. So there we go. I found out that Dean Alamang, who wrote Semantic Web for the Working Ontologist, is speaking at this conference. So I've got my answer there. So in this world where we now understand we've got documents and we've got a graph model, and we know there's some pros and some cons to those, how do you approach data modeling? So where should my data go? Okay, let's start with documents. So your data should go in a document, I think, if what you've got is a collection of information about a single entity. And the definition of entity is going to be down to your business processes and what you're modeling. But if it's about the same entity, it should be in the same document. Another thing to consider is update. If a delete should get rid of all of the information together, maybe that should be in a document together, which is then going to make it one operation. It should be in a document if you want to do document search, particularly if you want to do full text search, but other kinds of document search as well. You're going to need your data in a document. Another way that I like to think about it is to think about how you need to fetch your data. And if all the data in that document, if you need to retrieve it all at once, then that should be in a document because it's very simple, single document fetch, very quick. And rather than finding lots of pieces out of the database, one fetch is much quicker. And I'd suggest to you that it should be in documents by default. I think that's a good kind of rule of thumb is can we put it in a document? And if it doesn't fit in a document, then maybe we consider something else. Now I'll come on to qualify how you can use documents and do triples from the same documents at the same time. So, however, on the flip side of things, if you're going to model something in triples in the graph, one of the good reasons to do that is if the information is a relationship, if it's a link. And another way to put that, I think, is that the information belongs or could belong to more than one entity. If it's not obvious that it should go with that entity or it should go with that entity, then maybe it belongs as a kind of free-floating triple in neither of those documents. A kind of a converse from the document side. When you do a delete operation, if you just want to get rid of that link, and the things on both sides, they don't go away just because you got rid of that link, that relationship, then I think it's a good candidate for a triple. And we already touched on this, but if you need to do graph queries, then you probably want to be using SPARQL because it's so powerful and able to do that well. So in that case, maybe it should be in the graph. And at the end of the list, I guess, if you already have data in RDF, then, why not keep it as RDF? That's fair enough. So from my perspective, this weights things a little bit towards the document side of things. Obviously, MarkLogic has started as a document database. But even if, sorry, that's a little bit premature. Even if you have things in the documents, you can still actually use them as triples. We'll look at that in a second. And the other caveat is that you may have a first stab at trying to model your data, but actually with MarkLogic, because you can change the schema, you can have sparse data, you can do what we sometimes call progressive enhancement, which is the data hub kind of promise, the one where you only model what you need right now and later you change it and model some more. You have flexibility to go back and change decisions that you've made. And so nothing is permanent in that sense. You're not gonna have massive issues down the road if you did your modeling wrong first and now you want to change your mind. Okay, so how do documents and the graph work together in MarkLogic? Okay, so here's a graph, and obviously, there's some relationships modeled here, but you can imagine that there's a whole bunch more information about this character here and the blue van that he rented. There could be a lot more data about that. So there's one of the example kind of triples, one of the edges there. And in RDF, the nodes in the graph are labeled with an IRI. Okay, IRI is a slightly fancier, souped-up URI. It's an international resource identifier. And those IRIs can also be used to name documents. And the most obvious way to use the documents and the triples together in MarkLogic is for the IRI for each node in the graph to point to some kind of document. And then you can easily go and fetch more information about that node because there's information pointed to in the document. So I promised to come back and talk about what you do if you wanted the data in both places, effectively. What we have since MarkLogic 9 is this great technology called template-driven extraction, TDE. And it's really changed the way that I think customers can use MarkLogic and made it a lot more effective. So TDE allows you to write a simple description of how to take a document and create some triples from it. And that all happens at index time. So before, when your document is committed to the database transactionally, the triples are there already available for you. And when the document goes away, because the triples are really just index entries, all of the triples that have been extracted from that document also go away at the same time. So you've got the same benefits of lifecycle management when you're doing updates and things like that. That allows you then to create multiple formats sorry, I've written this the other way around. So that also allows you some flexibility so that if you've got two different types of documents that look very different, they can actually nonetheless create the same types of triples. You just create one TDE template for document type A and one TDE template for document type B, and you use the same RDF vocabulary, the same link names, link labels, and suddenly you've got a way to have a single view over multiple different formats then. So this is what TDE looks like. Slightly abbreviated, but you can see here's some data here. Here's a template. This is going to extract some triples. So first of all, it's going to match documents with this path. And then it's going to navigate. Well, here it's creating an IRI out of the node URI. That's a function that gets you the URI of that document. And it's creating a triple that refers to the age from that document. So fairly simple there. And another way that you can use TDE, that's worth mentioning, even though this is a talk on semantics, TDE will generate tables for you as well. And so those tables can be used from SQL with our SQL support and be available to like BI tools and everything that connects over ODBC. And those tables can also be available to Optic API queries. And we'll look at Optic briefly in a little bit later. Okay, so yeah, it has a lot of the same advantages, creating tables with TDE as creating triples with TDE. This is what a template would look like that was creating a table. In this case, you haven't got subject, predicate, object in here. You've got a definition for where to find values for each column in that table. And here's the Optic API slide. So Optic API is another way in which MarkLogic makes it simple for you to work with both documents and triples and mixtures of the two. Where SPARQL is defined to work over the RDF graph, and then I guess by parallel, where SQL is defined to work over the tabular views that we've got, Optic can work over views, and it can work over triples. You can embed little fragments of SPARQL into your Optic code, similarly SQL, and then it can combine all of those. And in fact, it can go and fetch documents and do operations on the documents as well. Not quite all, but most of the functionality, the query functionality that's available to you in MarkLogic is available in Optic API in a nice kind of relational style of kind of, it's a bit like a query builder in terms, if you've ever used a query builder. You chain all these operations together and it builds a query plan that we optimize and then we execute for you. Okay, so having understood maybe a little bit about how you might data model, I just wanted to give you some insight into how we're storing these things internally and what's going on under the covers. Okay, so one of the first ways that we had in MarkLogic before we had TDE, all triples used to look like this inside documents. There's an equivalent JSON format, but all triples used to be in this namespace in this format in your documents. And when the indexer sees that format, it creates an index entry in the triple index for that triple. And now we have TDE. We're still creating index entries in the triple index. You just don't have to use the exact format that you see on the screen here. But actually something that's important to note about MarkLogic is that we're a document database, and actually even when we're talking about triples, they still exist in some document or other. If you give us a bag of triples, we're happy to ingest that, but we're creating documents internally and putting them in the database for you. You don't need to understand the documents that are happening underneath that process, but there's actually quite a lot of power that you can get from understanding those documents and maybe even designing the documents to be useful, to have all the information for a given entity. Okay, so you could think of the triple index as looking a little bit like this. So, it's a bit like a table with entries for subject, predicate, and objects, and document ID, and potentially positions as well, but that's used less often. But the document ID is interesting because every triple exists in a document, and every triple knows which document it came from. We use that information all the time, in fact, because if the document has certain security settings, certain roles that are required to read it, the triple that's come from that document also needs to have those roles present in the user that's accessing them. So the security model there is inherited in that way. And there's other things that we use that document ID for. You can go both directions. So you can select documents and say, I'm only interested in triples from these documents. Or you can select triples and say, I'm interested to know which documents these triples came from. But in the classic kind of secondary school bait and switch, the triple index does not, in fact, look like what I just showed you. The values are actually IDs. And then there's another table in the not in the real sense, but in the kind of notional sense, that contains a mapping from those IDs to values. And so when you're looking at the triple index, you'll see that there are a couple of caches, for instance, and one of the caches is called triple cache, and the other one's called triple value cache. And that's what's going on here. Triple cache does this, and triple value cache does this, does the values table. So when we store tables in the triple index, that may seem weird to you. It's a triple index. What are tables doing in there? Okay, this is how it works. If you take any given cell in that table, you can give it a coordinate, which is the row ID, and then the column ID. I've identified that cell now, and that cell has a value. And so we make, effectively, we make the subject the row ID, and the predicate the column ID, and then we can store that information in the triple index. One of the nice things about the triple index is it's a sorted index, but it's actually sorted in multiple ways. And so you can see some of these ways here. We call them permutations. So this particular order is predicate first, then subject, then object. Okay? And if we're sorting all the predicates together, then if you think about what that means for the table, that means all the values of one column are next to each other in the triple index. Okay? So that is useful for us because we can access that and get all the values for that column. So that's columnar access. That's like a columnar database, basically, in relational terms. We have got an ordering that has subject as the major order. The subject is the row ID, so that puts all the values from one row together in the triple index. So that can be really useful for fetching whole rows at a time. And we'll actually make that decision for you as to whether we're fetching entire rows or whether we're fetching column at a time. We'll just choose the most efficient way to do that. There's another ordering which is predicate first, but then object as the next sort order. And you can think of that as all the values of a column together, but they're sorted by the object column, the actual value in that column. So that's useful for fetching columns in sorted order, and we can use that to optimize sorts because we can get the order directly from the index. Okay, so now you're very well informed about what's happening under the covers in the triple index. But I'd like to also look at a few common use cases. There are many use cases, but some of these we see over and over again. And so it's worth knowing what people have had success with in the past and what some of the common things that people do with this technology is. So this is one of my favorite use cases. So I'm a foster carer. And so I am thoroughly embedded in the world of social care and child protection and things like that. And we have seen some of the kind of most effective uses are simply using the graph to store relationships, to store links, and to bring data together. So in this case, what we have is we have this graph of relationships for this particular family. Things about where they live, things about who their relations are. There's no direct relationship to Jim here, but Jim lives at the same house, so there's obviously some connection with the child in this case. And the problem is, particularly in some of these cases, the information exists in different systems. So you may have information that is, a police report to say that this person went missing on a couple of different occasions. They've gone missing. That's in the police database. You may have some court records that say that there's convictions here for some of the people in this graph. You may have some school report information in the school system that expresses different concerns in other ways. And each of those systems is unable to contribute to the whole view of whether this child is at risk or not unless you understand the relationships that are there and you understand the bigger picture of being able to tie all of these systems together. Okay, so in that case, you're improving the protection of the child in this case because you're able to link together different information from different systems, and in fact about different people here, but all those people are relevant to the case. So I'm going to do some demos of some of these. That one I didn't have a demo for. But another obvious use case is to extend and improve the search functionality that we already have in MarkLogic. And the general way that you do that is you'd have domain-specific knowledge that's particular to your industry, to your application, and builds the smart search using that domain-specific knowledge. Often that domain-specific knowledge will be in the form of taxonomies, of graphs of information and how concepts are related to each other. So in this case, BSI, they actually had, so their application searches for standards for manufacturing medical devices. Okay, so there's all sorts of standards that apply if you're doing things in that space. But they had a problem, they had a recall problem basically. If you go and, for instance, search for pacemaker on their system, there are a handful of standards that would apply to a pacemaker. But a pacemaker is a type of implanted device. And there's a whole heap more standards that apply to implanted devices. So if you want to get a full picture of what standards apply to my situation, you need the domain knowledge that says, there's a link here, the pacemaker is a type of implanted device. And you can improve the recall by expanding the search, taking the search terms and looking them up in that graph, finding what's related, and also searching for those things as well. So we can actually see that in practice. If this works, it does work, but it's almost certainly not big enough for you to see. Hang on. How's that at the back? Can you see that? Okay, good. So first off, I'm just going to insert some data. You've seen this data on the first slide that I had. Well, we've got two addresses here, and these addresses differ in significant ways, although they seem to be, giving the same type of information. You can see that, for instance, this document has got a shipping address and a billing address, so it's got two addresses in there. You can see as well, if I scroll down to the bottom, this document has got different types of phone number. Okay, not uncommon. Whereas the top document, this only has one space for one address. And you can see that some poor relational schema guy has struggled with the fact that there's only one phone field. And they've done what everyone does and put some human ingenuity in here and shove two phone numbers in the same string, okay? Useful if you look it up and present it on a screen, not so useful if you actually want to make sense of this data from an application. Okay, so I'll go ahead and add those documents. And right off the bat, without doing anything, we've got search available to us. Okay, so there I've just searched for the word Paul, and we've got back a document for that. Now, what if I wanted to add some domain-specific knowledge here? So in this case, what I'm adding is some understanding that people are called by different names. This could be nicknames. I mean, it could be, thesaurus expansion of domain names or whatever you're doing there. But I'm going to say that Paul, as a name, it could also be known as Pablo, could also be known as Paolo. So we add that. That's just adding some RDF to our graph. And I can use that information then. And the pattern is fairly simple. I'm going to do a pseudonym query for Pablo. Okay, pseudonym query is a little function that I wrote, and it's very simple. So the first thing that function does is it's going to apply this SPARQL query here. And that SPARQL query says, given a name, I'm going to pass in this value to the query. So given a name, I want to follow links, also known as links, to find out what other names I need to look up at the same time. So here's the function. We run the SPARQL query here, and we take the values that get returned, and we pass all of those values in as a word query. Instead of just one word, we're passing all of those in. So now when I search for Pablo, that gets expanded, and here we've got our document back with Paul in it. So we've done a better job of search by using that domain knowledge. Right. So we talked a lot about Data Hub this week. One of the technologies that's embedded in the Data Hub framework is entity services, and so we end up asking you to define entities and the properties they have and relationships they have. But one of the fun things about the way that we do that is that data is all available in the graph from RDF, from SPARQL with RDF. And we can therefore extend that entity information with our own information. So, whilst there's a vocabulary that entity services gives you, you can add even more information to that. And we'll look at some ways in which that's useful. Okay, that's probably. I'm running low on time. So this is the entity description format for the document. We use a TDE. It ships with the product. And this description will turn up RDF data that looks like the right-hand side because of that TDE. I'll come back to that. Okay, so here's my entity description for that data that I just loaded. Customers, there's some addresses and phone numbers, and they're defined lower down. Here's an address. It's got all the usual parts to it. Here's a phone number. So I can add that entity description in. And just to prove to you, here's some of the RDF that entity description produced because of the TDE that's in the database. Now I can add some more information. So what I'm doing is I'm going to add information about how that entity model maps to each of the different types of documents I've got. So here I've got, for a customer, the given name can be found at this path. There's nothing special about this data so much as the fact that I'm recording it right now. It's not going to do anything unless I do something with it. But I can add that information in. And some of the things that you may be, just an example, but what you may do with that data is you may use SPARQL, and honestly this query is a little bit longer than it's probably worth me going through right now. But I'm going to use that information to create TDE templates for each of those source documents. So I can do that right now. So I've looked at the entity descriptions, and I've looped over those and looped over the source documents and found the information I need for which paths the data's at. I've generated that, put that all into a TDE document, and now I can do something really quite nice. So one of the things I can do is I can do a query for this phone number. And we're doing a query, we're looking it up in the triple index here. That's what triple range query does. And when it comes back, you can see that that's one of the phone numbers that was in that string field, which was, had a bar in it. But we've done an exact match on that phone number because the TDE that I generated is able to do some string manipulation and take out each phone number individually. That's also given us a graph, and we can query that graph. So here is a simple SPARQL query. So I'm looking for addresses in San Francisco. And there we go. We've got 2 addresses. An example of sparse data there is the type here. This one's a shipping address. This one doesn't have a type. Yeah, it's fine. It can handle that. Now, quickly moving on. And one of the things that we've heard talked about from the stage today, in the keynotes, is the idea that you might have provenance information that tells you where your data's been, and what's happened to it, what processes it's been through, and changes it's been through. And so this is the kind of information that you would add as provenance information. Now, actually, things have progressed since I first wrote this slide a few years back, and now the Data Hub is producing provenance information directly into the database for you. But of course, there may be operations that you're doing that are not related to Data Hub, and you can still use the graph to add provenance information. And I'm going to run through these really quickly. But this is creating the kind of envelope documents that Data Hub framework creates for each of those sources. But as it's doing it, it's running this SPARQL query here as well. And this SPARQL query is producing some triples provenance information about the transformation we just did. And because I've produced that information and in the same transaction, I've committed that to the database along with the process documents, I can, just a second, I'm going to skip those ones. What I'll do is this workspace that I'm using in Query Console, I'll ask them to publish that along with the slides from this talk, so you can come back and have a look at this. We can then query that provenance information with a SPARQL query. And we can say something like, what data was generated by from this entity description at a certain time. Obviously, I just did that, so the time is now, but it might be more interesting to say what happened last week. And there's the information back. We know, so if we're tracing a fault, if we're saying, well, that entity description was wrong, we know what's used that entity description. We can go back and maybe fix our mistakes or something like that. So, in conclusion, I think I've talked about lots of different aspects of this now, but some of the things I'd like you to take away with you is that semantic graphs complement a data integration project and work really well together. And I think that's the reason why most of our customers now are in some way using semantics. But do think about choosing the right model for your data and for your application needs. And the two of those play into each other, which is why we looked at what the data model's good at, but also how it gets queried in that format. But do remember, there are good ways to benefit from all the data models in MarkLogic. And you don't necessarily have to choose one or the other now that TDE is available to help you put the data in both places. And we looked at these 4 different use cases. Linking and relationships is the easy one. Semantic search, bringing domain-specific knowledge to improve things. Extending entity models and producing metadata like provenance for your documents as well. So I will open the floor up to questions now, if you've got anything to ask.
Anyone? Yep.
Do you have a favorite anti-pattern that we should take to heart and when creating multi-model databases in MarkLogic, specifically using graphs?
Well, that's a great question. Honestly, my favorite anti-pattern is thinking that MarkLogic is a triple store and ignoring all the rest of it. You're really not getting the most power out of MarkLogic. You're making your life much more difficult than it could be if you're ignoring documents and just using the graph.
Any other questions?
So when you're modeling data that's truly relational, so say you have a product category that changes quite frequently, and it's in thousands or millions of records, will updates to that that triple cascade down to the other, or you have to denormalize them back into all those documents?
I mean, yeah, I mean, we don't do, I mean, in the sense of relational databases, we don't have any like cascade triggers or anything like that would work. It's going to be up to you. You know, if you, in the case of categories, if you had categories as a kind of entity, you had an artifact for that category, you know, then you're just going to have to change, you're going to change it in one place. Yeah. And all the links, you know, will then get that update. It's similar in relational, I suppose. But if you had that category as a field in each of your documents, if you wanted to change the name of that category, then yeah, you'd have to go and update all of those documents. So you know, you need to look at your usage patterns there and what might be a common operation.
So if you don't put it in the document itself, will the contents of that category document also be included in the product document in the full text searching? So full text search identifies documents. And so if you search for something and it was in the category document, you'd get the category document, but you wouldn't get everything that referred to that. Okay. So yeah, you'd make your life more complicated in that case. Okay.
But I think, I'll just speak up. I think that's the case.
The people at the back can't hear you. They're in the other room.
Oh, it's another room. So, but I think that's exactly what you did in your demo, right? Where you expanded the query so that you use the category to expand to what you are looking for in the document, and then you query on that. So you just do a little query expansion before, and then you can update your categories anytime you want, if I'm not mistaken.
I mean, yeah, that would certainly work if you kind of got more fine-grained categories or something like that, wouldn't it? Yeah.
Oh, wait.
Once you have your triples in the MarkLogic, the triple store, what are URIs that you can put on top of that so your users can get to that triple store and use the graphing and be able to manipulate the data graphically?
Graphically?
Visually.
Visually, okay. I mean, we don't ship with anything that would be like a visual editor. We have partners that do that can connect to us. One of the nice things about SPARQL is it's actually not just a query language. They define a REST API as well. We implement that REST API, so there's a lot of standard tools that can connect to that and view and change and model the data that is in MarkLogic. See if I think so. Pool Party is one of those. SmartLogic, I think, is another one of those. So, but I'm not a comprehensive list of all the partners we have.
One more real quick question, and we could probably squeeze one. Oh, the decisions.
Oh dear. I won. I just want to, maybe I'm not should not have won, but you mentioned in a slide that the choice between document or graph was whether, if you're going to delete the object that should be your driver between the choice representing in graph or document. Now, if let's say, for example, we have a concept of a person as a document and a car as a document, and the relationship of is ownership, but with the ownership itself is, the price paid, the date of purchase, and all that. So you have a number of associated properties with the relationship itself. How would you go about storing that? Would you make a separate document and link all three together? What would be a good model for that?
Yeah, I mean, I think you'd have a choice to make, wouldn't you? And that depends on some of those factors. I mean, you could say that a person carries with himself the record of his purchases, all right? Or you could say that the car carries with it the record of its purchases. Or you could say, actually, purchase is important to me in my application. Purchase is an entity in itself, in which case the person points to a purchase and the purchase points to the car that's been purchased.
Got it.
We're actually out of time. Maybe if you can answer questions out in the front, but I've got to kind of cut you off here. Thank you all very much. If you want to stick around in this room, the next session in here is data security and MarkLogic, securing all the things. If not, please fill out your survey, and thank you guys very much for stopping by.